Dear students, in previous lectures I have told you and taught you on nodal analysis. Now I will give you a short description on supernode analysis and how you could solve this kind of mathematics. First of all, you have to understand what is supernode. Okay, at node points we always take voltages that has been recognized as nodal voltages. You can see here there is two nodal voltages V1 and V2 has been marked here. That is the V1 and that's V2. And if there is a source voltage, there is a DC source voltage is connected, it may be DC or AC, any kind of voltage sources. As it is a AC source analysis, if any kind of source without any resistance, inductance or capacitance, that means it's not the network, it will be situated between the two voltages. If there is an external voltage source is added between the two nodes, then we can call it a supernode situation, and the analysis will be supernode. In that case, what can we do? First of all, you have to just remove this part from the nodal analysis. Just remove this part. Okay, you have to just remove this part. Now we go on to the book. Now you can see here in example 10.2, you have to solve the equation supernode, compute V1 and V2 in the circuit of the following circuit. Okay, so according to nodal analysis you can easily solve this kind of analysis. In the previous lectures you can easily find it out. Just look at this method. If we just remove the part from the previous section and just after removing it, we can recognize it as a supernode. Okay, that has been written as a supernode. Okay, now here you can easily analyze nodal analysis. How you could do? As you know that there is a V1 and there is a V2, and there was a voltage source around it. So you can easily write this equation V1 minus V2 equal to the 10 volt 45 degree of phase. Okay, so that will be the difference. Okay, then you can analyze it clearly. V1 minus V2. Now just get on to the next section, that at nodes 1 and 2 from supernode they can get this. How can they get this? Look back onto it. Here 3 ampere is the source. Okay, go to the previous section. Here you can see 30 degree amperes. So that will be a 3 ampere. It's a current that is flowing here, and it has been divided into the other 3 parts. Okay, if we connected all the points and removing the voltage and whatever else there might be, the total network has been removed. So you can see that there will be an entering current and 3 outgoing currents in that section. Just to make a supernode, as we know, a node divides its current itself. There may be incoming current and outgoing currents are there. So there are 3 outgoing currents in that section, and on 1 incoming current. So at supernode, at node 1, we can easily write the incoming current will be 3 ampere here, and the outgoing current will be this and that. Okay, 3 currents are there. So 3 ampere is equal to V1 divided by minus J3 ohms. As you know, we have to just convert any kind of equation, any kind of circuits to the frequency domain. That means the complex format. Now plus the other 3 currents will be plus because they are outgoing currents. So there might be V2 divided by J6 ohm, and another V2 will be divided by 12 ohms. As there are 3 other branches, this branch has been dominated by the V2 and this branch has been dominated by V1. So you could easily understand by Kirchhoff's current law. We have been applying Kirchhoff's current law in that section. Okay, now just get back onto it. In the previous section, in the previous supernode analysis, you can easily see here. Okay, and after calculating it, you can get this. That's the equation. Okay, now get back onto it. Previously we have taken that V1 minus V2 is equal to 1045 degree, and this V1 is equal to, now we can say V2 plus this, and this equation and the previous equation equation 1 and equation 2, if we substitute this, we can easily find out the V1 and V2 out of it. Okay, you got it? That is exceptional section of supernode analysis. I hope you will understand, you understand clearly, and you will rewind this video and look upon the important parts to study and understand the node analysis very clearly. There is a practice problem given here. That is also a supernode analysis, because V1 and V2 here is 160 degree, 100 voltage, 60 degree voltage has been given here. So it is also a supernode analysis. So first of all, take V1 minus V2, that is supernode, and that will be 100 out of 60 degree phase advance, 60 degree phase advance, 60 degree. Okay, so you can easily get this. That is the equation number 1 or equation number 2. After, you have to just remove this part and then calculate it. If you remove this part and make it a supernode, so there will be an entering current and the 3 outgoing currents are there. You can easily find out these 3 equations as far as nodal analysis, applying the Kirchhoff's current law in that branch. And if you want a help or a hint, I can give you a hint. That's the V1 and that's the source voltage. So you can easily write V1 minus 75, V1 minus 75 divided by these 4 ohms. So you can easily get the incoming current. Okay, 4 ohms, and that will be equal to the another 3 currents here, V1 divided by J4 ohms, and all other things will go through. V2 divided by minus J1 ohm plus, and other V2 divided by 2 ohms, you will get minus J ohms, and plus V2 divided by 2 ohms. You can easily find all other things with that. If you find any kind of problem, just give me a message. I will give you the hint of this mathematics. Just do it yourself. Thank you very much for being with me.